Hello everybody. So I will be doing chapter 16 for our data analytics tutorials. So in this chapter we'll be doing downloading data. So in this chapter we're going to download data sets from online sources and create working visualizations of that data. So we can find a variety of data online, much of which hasn't been examined thoroughly. The ability to analyze this data allows us to discover patterns and connections that no one else has found. So here we have our Sitka highs and lows.py. So this is a weather plot program. So this program reads weather data from a CSV file and creates a line graph showing the daily high and lows temperature of Sitka, Alaska in 2021. So what the code does, it reads the CSV file. So it'll open the Sitka weather 2021 sample.csv. It reads all the lines and uses Python's CSV reader to process them. The first row is the header row. It contains the column names. It's going to extract the needed data. So for each row, it pulls out the date, the high temperature and the low temperature, and then the date string is converted to Python datetime object so it can be plotted correctly. And then all values are stored in lists, so the date, the highs and the lows. And then it will create the plot. So matplotlib is used to make a graph. Red line is the daily highs, and then blue lines the daily lows. The shaded region between them shows the temperature range, and then it's going to format the chart. So title is needed, and the date labels are rotated for readability. The y-axis is labeled temperature, and text axis are increased for clarity, and then it will display the final weather graph with our PLT show. So we'll open a window with the finished plot. So let's run this. Okay, my laptop is slow, but we'll wait for it. Well, okay, it's taking too long to open. I'll just move on to the Death Valley. whilst it's okay. There we go. So we have our date, the high temperature, low temperature. We have the red line, which is our daily highs, and then we have the blue line, which is our daily lows. Then we have our title, which is the daily high and lows temperatures 2021. Yeah, this is our Sitka highs and lows. Then we have our Death Valley. Let me just open it since it's going to take long to open too. So yes, so in our Death Valley weather program, so it's the same thing as our Sitka highs and lows. Then this program reads weather data from a different CSV file, which is the daily high and low temperatures for Death Valley in 2021. It also handles the missing data safely. So it reads the CSV file, the Death Valley 2021 CSV, extracts the highs and lows, um, then the program tries to convert the high and low temperatures value into integers, and if any value is missing or invalid, the program prints missing data for date. That day's data is skipped. And then the valid data is stored in the three lists: dates, highs, and lows. And then it also plot the temperatures: red line daily highs, blue line daily low temperatures. And then it will format the graph and display the graph. So let's Python Death Valley. Okay, so the program printed. Sorry, let me just close this for now. So these are the missing data for our date. So missing data for 2021 0504, and then this is the missing data, and then this is our graph. So this is the final graph showing Death Valley's temperatures. So our highs and our lows, temperatures and our dates. So we have our global earthquakes visualization program. So this program reads 30 days of recent earthquake data from a GeoJSON file and plots the earthquakes on a wildbird using Plotly. So it will load the GeoJSON earthquake data. It will extract key earthquake information, which is, so for each earthquake, the program pulls out magnitude, longitude, latitude, and the title. Then these values are going to be stored in a list, the mags, the longs, the lat, and the EQ titles. And it also plots the earthquakes on a world map. So using Plotly Express, the program creates a scatter map. So for every earthquake every earthquake will appear as a point, and then the size of each point reflects the earthquake's magnitude. The color of each point also depends on magnitude. Then the map projection is natural earth. So hovering over a point will show the earthquake's title, and then it will display the interactive figure, which is going to be our map, where can hover to read the full earthquake details, plan on the globe, zoom in and out of the map. So when we run our program, this is what we get. We have a magnitude here. When we go to the point, and then we see it's Santa Cruz de Flores in Portugal. We have the size, the latitude, the longitude, and the magnitude. So for every point that we have here, the information will pop up here. Okay, I hope everything was clear. Thank you.